Hello, so today we're going to focus on sketching these three graphs, the graph of cosec x, the graph of sec x, the graph of cot x. So we looked at what these definitions were yesterday. So just as a reminder, cosec is 1 over sine x, sec is 1 over cos x, and cot is cos over sine. So that's just a reminder of what we did yesterday. And so today we're just going to look at how we sketch these graphs. So let's start with the cosec graph. So cosec again is 1 over sin. So a sine graph between, let's say, yeah, from 0 up to 2 pi. It looks something like this. That's our sine wave. We're going from 1 to -1. So our cosec graph, so 1 divided by the y values on this graph here. So 1 divided by the y value is 0 there. Well, that's going to be undefined. So 1 divided by 1 at pi over 2 here. So when x is pi over 2 on the x-axis, so on our x-axis that, pi over 2. So 1 divided by 1 gets you 1, so you've got 1 there. And now what's happening here is that if you pick a really small angle here, your y value of sine is going to be really small. So 1 divided by a really small sine value, that's going to give you a very big cosec value. So what's really happening here is that the graph is kind of starting from above, and it's going down and down and down until it gets to this minimum this minimum point here in the domain, between 0 and pi here, whereby it reaches 1 here, like our minimum in this part of the domain. So then it's going to increase, because as the sine value gets smaller and smaller and smaller, 1 over sine actually gets bigger. So now we're going to increase until again we get to an asymptote at pi, at x equals pi. And why is that? Well, that's because again we know that sine of pi is 0. 1 divided by 0 is undefined. So yeah, you're going to get this kind of almost like a kind of quadratic shape, but not quite actually a quadratic shape. But you get this kind of U-shape graph. And then what happens down here is kind of like a similar thing between pi and 2 pi. It's going to repeat itself like this. So it's going to actually do something like this. So you've got, again, an asymptote at 2 pi, because sine 2 pi is 0. 1 divided by sine 2 pi will give you an undefined value. So you get an asymptote down here, and you get kind of like this local maximum point, I should say, here at 3 pi over 2. So basically when the angle is 270 degrees. So you get the kind of this shape, and that's again because sine divided by -1 gives you -1. Sorry, 1 divided by -1 gives you -1. But as the sine value has a smaller magnitude with these kind of angles here and here, 1 divided by a number with a smaller magnitude gives you a number with a bigger magnitude, so it gets more negative in these corners here. So that's what cosec kind of looks like. And what we can see is, I mean, what's going to happen is that the graph will again repeat itself like this, with more asymptotes here, repeats itself like that. So again, this graph has got a period, just like the sine graph. It's got a period of 2 pi. So it repeats itself every 2 pi degrees. And you have asymptotes. So you have asymptotes at multiples of pi. So pi, 2 pi, 3 pi, minus 2 pi, minus 3 pi, etc. So asymptotes are at x equals k pi, where k is just a whole number. K is an integer. Okay, so that's the cosec graph. How about the sec graph? So very similar actually, because we know the cos graph is basically just the sine graph translated to the left by pi over 2 radians. So actually, yeah, we're going to get pretty much the same kind of shape here, but just translated to the left by pi over 2 radians. So again, you could do this analysis where you draw your cos graph in. Obviously you've got pi there, you've got 2 pi there. So again, you could do this kind of analysis where you say, well, 1 divided by 1 gets you 1. 1 divided by 0 at pi over 2 is undefined. So, I mean, you know that you're going to get your asymptotes, pi over 2, 3 pi over 2, and so on and so on. So you know that for a fact. You get your asymptotes there at pi over 2. You get your next one at 3 pi over 2. And yeah, all these asymptotes are going up in odd multiples of pi over 2. So 1 times pi over 2, 3 times pi over 2, 5 times pi over 2. So all these odd numbers times by pi over 2 will be your asymptotes. And again, what's happening with this graph is actually it's going upwards again like that till it goes to its until it kind of asymptotically approaches the asymptote. And then down here, we're getting kind of this, and obviously this is 1 here, the coordinate 1, because 1 divided by 1 is 1. And then again, it's doing the same thing as this cosec graph, but just shifted to the right by pi over 2. So now we get pi in the middle there. We've got a y value there of -1, because again, 1 divided by -1 on the y-axis gives you -1. So it's going to give you kind of a shape like this. Again, this kind of curved shape where it's asymptotically approaching these asymptotes. So that's what you would get there and there. Sorry, there should be a 3 there, just make that clearer. And of course, yeah, the graph is just going to repeat itself in a similar fashion to like the cosec one. So that'll be your sec graph. So again, we've got a period of 2 pi. So the graph is going to repeat itself every 2 pi radians. And again, we've got these asymptotes, but this time at odd multiples of pi over 2. So asymptotes at x equals pi over 2 times by odd numbers. So I just say 2k plus 1, where k can be any integer. So that's where we're getting our asymptotes pi over 2, 3 times pi over 2, 5 times pi over 2, or -1 times pi over 2, -3 times pi over 2, and so on and so on and so on. So that would be sec. And now cot. So cot is cos over sin. So if we think about the sin over cos graph, I mean that's actually the tan graph. So this is tan x. And we know that tan looks something like this. You've got asymptotes again are like these odd multiples of pi over 2. So your asymptotes there. And then the graph goes through 0 at 2 pi, 0 at pi, 0 at 0. And then again, you've got these asymptotes pi over 2, 3 pi over 2. But remember what we said in yesterday, that actually cot is not the same as 1 over tan. So it's not the same as that technically. It's cos over sin, which is actually slightly different at these asymptotes. So basically, yeah, if we just look at yeah, so what we said again yesterday, just to remind you, is that cot does equal 1 over tan apart from when x equals, again, these asymptotic values of x, so odd multiples of pi over 2. So pi over 2, obviously, again, this is pi over 2 there. This is 3 pi over 2. So these odd numbers times by pi over 2, this is the place where these are the x values such that the cot graph or the cot function is not the same as the 1 over tan function. So you just got to be careful here. So everywhere else is the same. So 1 divided by 0, again, that's going to be an asymptote. So we get an asymptote at x equals 0. And then slowly we're getting bigger and bigger and bigger. So as you divide by a bigger and bigger number, 1 divided by a bigger number, you're getting smaller and smaller and smaller. So it's going to kind of look like this. So you're starting from above, you're going down below, and then actually eventually, even though this is undefined, and technically 1 divided by an undefined number is undefined, remember when x equals pi over 2, cot does not equal 1 over tan, so it does not equal 1 over this. It actually equals cos over sin, and cos over sin when x is pi over 2 is actually 0, because cos pi over 2 is 0, and cos pi over 2 is, sorry, sin pi over 2 is 1. 0 divided by 1 gives you 0. So actually, yeah, it's going to actually go straight through 0 there at pi over 2. And then what's going to happen down here? Well, I mean, again, if we think about it, we've got an asymptote of pi there. So again, we've got asymptotes at these multiples of pi. So these are actually whole number multiples of pi, 2 pi there. But what happens is, yeah, so it continues through 0, because again, cos over sin is defined when x equals pi over 2, because it's 0. But then, yeah, as we're going, I mean, if we start from pi and we're going to the left here, so as we go to the left, the tan values are getting more negative and more negative. So bigger, more negative values. So what happens is that this fraction 1 divided by more negative numbers gets you it's going to get you a fraction with a tinier magnitude. So basically, yeah, so we're starting from below here and then we're going to there. So that's what that's going to look like there. And then again, the graph's going to repeat itself. So again, the tan graph has a period of pi radians. So that means the cot graph has a period of pi radians too. So it's going to kind of go like this. And again, going straight through at 3 pi over 2 and down like that. So with this cot graph, the period again, like the tan graph, is pi radians, and the asymptotes are actually at these odds. Sorry, not odds. Sorry, they're actually at multiples of pi. So x equals k pi, where k is an integer. So yeah, that's how we can sketch all these graphs. So we looked at the cosec graph, we looked at the sec graph, and now we've just looked at the cot graph. So that's how you would sketch cosec, sec, and cot.